The very first problem. So support for 8.2. The very first problem that I have says x times b minus 4 plus z times b minus 4. This problem isn't already a factor by grouping problem. It's like almost practically solved for you. So when you see something that looks like this, and these things in the parentheses are the same, so both of them are b minus 4. When you're working the problem, those two can come together. And then they have to be exactly the same for that to happen. But then you put the rest of your stuff together and you get x plus z. So that would be factored. And that technique is called factor by grouping. They've already got that kind of broken down for you. The problems kind of progressively get harder. So on number 2, they've got 3x. And then they've got times 5x plus 6 plus 2 times 5x plus 6. So to factor by grouping, what you're doing is you're looking to see if the thing in the parentheses are the same. If they are the same, then you can pull those out and put them in one parentheses together. And then the other stuff goes in another parentheses. That's the answer. That's how you factor by grouping. So on problem number 3. Okay, this is for the first time, we're kind of turning it up a notch. On problem number 3, we've got x to the 3rd plus 3x squared minus 6x minus 18. All right, so we don't have what we had in problem 1 and 2 with the parentheses. So the goal is to make what we had in problem 1 and 2 with the parentheses so that we can factor this. So what you should do, and most of these are already set up where all you have to do is take and divide right down the middle these two terms. So you want two terms in the front and 2 terms in the back. Okay, then you look at the x to the 3rd and the 3x squared and you say, well, what can I pull out of both of those? To me, it looks like both of them have at least an x squared in them. So I could take out an x squared out of both of those terms. I can't take out a number because there's only a 1 here and a 3 here, so there's no number I can pull out. If I take an x squared out of an x to the 3rd, I'm left with an x to the 1st. If I take an x squared out of 3x squared, I'm left with a plus 3. Okay. When you multiply that back out, x squared times x, you should get x to the 3rd. X squared times 3, you should get 3x squared. I always go back and make sure that I did that correctly. So listen, the goal here now is that if this is an x plus 3, then I need in order to do this factor by grouping, I need this to be an x plus 3. So you can almost always put that there and go, can I make this work? So I look at these two terms, -6 and -18, -6x and -18. And I say, well, what's the biggest thing I can pull out of -6x and -18? And I think I can take a -6 out of both of those. So then I go and since I already know this is supposed to be x plus 3, I multiply it out and say, well, does that work? -6x. -6 times x is -6x. That's good. -6 times a positive 3 is -18, which is what it's supposed to be. So yeah, it works. X plus 3 and x plus 3, those are the same. It doesn't really matter if you put this in the front or the back. I just always stick it in the back. And then you want to put the other part, the x squared minus 6 in the front. Okay. So the goal is that you come up with these two parentheses that are just alike, and then you can pair them up. The last thing you need to do is look at this term right here because there's still an x squared here and there's a minus sign, and you need to see, is that the difference of squares? And we talked about this kind of at the beginning of the class. So some examples of differences of squares, difference of squares. Because if it is a difference of squares, you can keep going. X squared minus 16 is the difference of squares, because if I take the square root of X, I get X. I said that wrong. If I take the square root of X squared, I get X. If I take the square root of 16, it comes out perfect as a 4. So this is actually an example of the difference of squares. Difference is the minus sign. So it could be broken down into X minus 4 times X plus 4. Okay, this one, X squared minus 25. Those are both perfect squares. It can be broken down to X minus 5 and X plus 5. Everybody okay with that? So is X squared minus 6 the difference of squares? X squared is a perfect square. It's the square root of X squared is X, but is 6 a perfect square? No, it's not like 16 and 25. I can't, if I take the square root of 6, it doesn't come out as an even number like that. So this is as far as I can go with that one. But you want it, if it has an X squared and a minus, you want to check and make sure it's not the difference of squares, and you, because if it is, you can split it up a little bit farther. Okay. Is everybody okay with that part? Okay. So let's go to making sure nobody's still writing anything down. So let's look at number 4. So number 4 says it wants us to factor 15s to the third plus 45s minus 25s squared minus 75. Okay, when I look at this one, the first thing I'm noticing is that there's something that's familiar with all of these terms. Okay, so what's the biggest number that'll go into 15, that'll also go into 45, that'll also go into 25, that'll also go into 75? First thing I want to do is factor out that 5, okay, because there's something that would go in every one of those. I'm going to pull that out. After I do that, I can say, well, 15 divided by 5, that's really just 3s to the third. 45 divided by 5, that's 9s. Negative 25 divided by 5, negative 5s squared. I'm not pulling out any variables, so that part's going to stay the same. And then negative 75 divided by 5, negative 15. I almost put 25, sorry. All right, is everybody okay with that? So I looked and see if anything. Now what you want to do is you want to see if you can factor out. You want to do this solve by grouping. So that's the whole goal of this activity. So you're going to divide that into 2. Most of these are set up kind of for your success so that everything's kind of already there in order. So I'm going to leave the 5 here. I know I still have to come up with that part. So I'm going to look at this. I'm going to say, what's the biggest thing that I can pull out of a 3 and a 9? Take a 3 out. Can I take any s's out if I've got s to the third and s? I can take 1 s out, right? Okay, that would leave me with, if I take a 3s out of 3s cubed, I still have an s squared. If I take a 3s out of 9s, well, 9 divided by 3 is still 3. And then if I pulled the s out already, I wouldn't have that part. So I would end up having s squared. I know that doesn't really look like it. S squared plus 3. Is everybody okay with that part? It would be really nice, which we know the whole goal is right here, that over here, I need to have s squared plus 3. That's what I'm looking for so that we can factor by grouping. So I'm gonna say, well, mate, let's see if this works. I've got a negative 5 and a negative 15. I could pull out a negative 5 out of both of those. I'm working backwards, and then I want to check and see, well, does that work? Negative 5 times s squared is negative 5s squared. Negative 5 times a positive 3 is negative 15. So yeah, that works. So to finish, we have the 5 on the outside. We can pull the s squared plus 3 together. We can also pull the remaining 3s minus 5 together. I'm going to put a line through my s's so they don't look like 5s. And that's it. This last term has an s squared in it, so I need to look and see if it's a difference of squares. But it's not a difference of squares because it's not even a difference. It doesn't have it's got a plus instead of a minus, right? So I don't have to worry about that on this problem. Number 5. W squared plus 4w equals 0. This one is asking you to solve this. Most of you can do this in your sleep because if you have your graphing calculator, right, you just use the quad program. So I don't feel like this is not one that's new to you guys. You could plug in A would be 1, B would be 4, C would be 0, and it tells you if it's asking you to solve it, it's going to give you the answers then. Are y'all okay with that, or we need to work that one? All right, number 6. Number 6 says 4a to the third minus 24a squared equals 28a. Okay, I feel like on this one, if we just move the 28a by subtracting it and setting it equal to 0, if it's asking me to solve this, the graphing calculator does that one for you too, if you just do the polyroot finder right under your apps. So we're good with that one, right? Use the polyroot finder to do that one. I don't mind going over these with you and showing you how to do it the long way. I just don't think that a lot of you are going to do that. And so please, if you want to know, let me know. 7v to the third equals 112v. Can the calculator do this one if we're solving it? We're not factoring it, we're solving it. Yeah, we could do, bless you, 7v to the third minus 112v. So we could use the polyroot finder under the apps and set our roots to third, the number 3, and type it in. It's going to tell us the answer. This one to me is really easy to just solve it. If I have 7v to the third equals 112v, I can divide both sides by v. Those would cancel out. On this side, this v is going to take away one of these v's, so we would have v squared. Then we would divide by 7. So v squared is equal to 112 divided by 7, 16. We'd have to take the square root of 16. Sorry about that. I don't think I can get it back. What happened there? Oh, wait, it went to page 2. I didn't know it could do that. So v squared is equal to the square root of 16. And so v would be plus or minus 4 on that one. So, but yeah, you could just also do this in your graphing calculator on those. That's cool. I didn't know they did that. Do you guys need me to go back? Or you okay? Number 8, b to the third minus 81b squared minus 4b plus 324. So I'm looking at it to see if there's anything I can pull out of all of these terms. They're asking me to factor this, not solve it. So I have to come up with it a different way, and there's not. So I want to kind of divide this right down the middle to factor by grouping. So I'm going to look here and I'm going to say, well, there's at least a b squared in both of those. I can't pull out a number because b to the third doesn't have, it's only a 1 in front of it. So I can pull out b squared. If I take a b squared out of b to the third, I've got b to the first. If I take a b squared out of negative 81 b squared, I just have negative 81. Okay, is everybody good right there? So the next thing I'm hoping is that this needs to be b minus 81 because these are supposed to be the same so that I can factor by grouping. So I'm looking at, in order to make that a b, and it was a negative 4b, I'm going to have to pull out negative 4. So negative 4 times b is negative 4b. Negative 4 times negative 81. You can check it, but it is positive 324. So that worked out. So we would put the b minus 81 in one set of parentheses, and we would put b squared minus 4 in the other set of parentheses. Okay. Is either one of these the difference of squares? Yes, right? B minus 81 is not, because it doesn't have, 81 would be a perfect square, but this would have to be a b squared. This right here is, because I can take the square root of b squared and get b, right? And I can take the square root of 4. It's the difference, the minus part makes it the difference of squares. I can take the square root of 4 and I would get 2. So one of them needs to be plus and the other needs to be minus. So that one would actually break up a little bit farther. Number 9. W cubed minus WG squared minus 9W squared plus 9G squared. I had a student yesterday go, I was doing good, and then they put 2 letters in there, which you do kind of feel like sometimes, like, why do they have to add something else? But I mean, follow the same things as you were doing. You're gonna look and see if there's something that everything has in common. There's no number that's in every one of these. So the next thing you're gonna do is divide this into 2 things. You're gonna look at those first 2 things, and the only thing that I see that both of them have is 1 W. There's at least 1 W to the first power in both of those. So if I pull out a W to the first power, I have a W squared left if I take one of those out of that W to the third. If I pull out a W from negative WG squared, that just leaves me with G squared. So I'm really hoping that right here, I can get a W squared minus G squared, because that's what I got here, and that's going to help me. So even if you look at the first term, negative 9W squared, well, that's going to have to be a negative 9 if I'm going to multiply those 2 and get negative 9W squared. So now I need to check the second. A negative times a negative is going to get me positive, right? Negative times negative, and then I've got my 9 and my G squared. So yes, that works. So we can pull this W squared minus G squared, and then we can pull W minus 9. Is there a difference of squares here? Yes, W minus 9 is not, because this isn't W squared. But both of these are perfect squares. The square root of W squared is W. The square root of G squared is G. It comes out even. So W minus G and W plus G. It doesn't matter whether you put the minus or the plus in the front, but it's the same thing. Okay. I'm sorry, what? Okay, so this one, 9 is a perfect square, but W is not, because it needs to be a W squared. But yes, if that was a W squared minus 9, it would be W minus 3W plus 3, but it needs to be a squared for that to happen. But yes, that's a good question. Okay, we good? So I am not going to work 11 because it's multiple choice, but let's look at 10. Negative 3x squared plus 2x to the third plus 4x minus 6. So we know we need to look and see if all of these terms have something in common, but they don't. Negative 3, 2, 4, and 6. We're not going to be able to take anything out of those, all 4 of those. So the next thing we want to do is we're looking at this first part. They both have at least an x squared in them. Negative 3 and 2 don't have anything in common, so I wouldn't take anything out of that. So I would get negative 3 plus 2x if I take an x squared out of both of those. Everybody okay with that part? So I know that I really want to have -3 plus 2x here. This is kind of, this right here is kind of written backwards to what we're used to seeing. So I'm gonna have to think about this and go, okay, well, to get, what am I have to multiply 2x to get 4x? What, it needs to be a +2. So let's see. So 2 times -3 would give me the -6. So that part's okay. And then 2 times 2x would give me the 4x. So that part's okay. It's okay that it's backwards compared to up there. So we've got x squared plus 2. And then we've got -3 plus 2x. And that's not a difference of squares because it's not a difference. It's a positive, it's plus. And most of the time, people are going to write the x term in front of the constant term. These two things are just the same thing. But most of the time, people will put 2x minus 3, not -3 plus 2x. Right? That's how you're used to seeing it. Okay, so I hope that kind of helps you with 8.2 support. I think it should. If you've not seen, it's not that doing the difference of squares is really difficult. It's just that if you haven't seen it, it can be. And I just want to make sure I went over that because it's really hard to follow the directions on the, like, view an example, I feel like, on those. So